All right, guys, we are going to go through the second set of monohybrid cross-practice problems. And if you remember the first ones that we went through, in those problems, we were primarily given genotypes, and what we were doing from those genotypes of the parents is finding the offspring. This time, we're going to do it, and we're going to kind of take up that level of intensity just a little bit. So in this cross, a tall plant is dominant to a short plant. If all offspring of a cross are heterozygous, what would the genotypes of the parents be? So this tells me all of the offspring are heterozygous. So I'm going to come here, and in my Punnett square, I'm going to put a heterozygous offspring everywhere. So if I know that, now I got to figure out where we're going. So if we remember before, we said that this guy right here, that allele has to come from one parent, and then the other one has to come from the other parent. So we're going to do the same thing here, because that allele was coming from there. And then if this capital T is coming from that parent, then this is, whoop, jump me back. Then that's a lowercase here. So the genotypes of my parents should be capital T, lowercase t, lowercase t. So homozygous dominant and homozygous recessive. So a round-seeded plant is dominant to a wrinkle-seeded plant, which is, we're going to use R's as our letters to use for our alleles. What parental genotypes will produce offspring that are 50% homozygous dominant and 50% heterozygous? So it doesn't really matter where we put it, but that homozygous dominant genotype is going to look like that, and then my heterozygous genotype is going to look like this. So 50%, 50%. How do we get that? Well, I know that I've got to get a capital R. So a dominant genotype to come for here and there. Then I've got to have another one. So we know both parents are going to be dominant. We're going to see that phenotype. To get this lowercase r, though, I need to have one parent that has the recessive. But down here, I still need this dominant allele. So again, my parents, the parental genotypes have to be capital R, which is homozygous dominant, and heterozygous. So these would be my two parents. Okay, homozygous round-seeded plant is crossed with a homozygous wrinkle-seeded plant. What percentage of the offspring will also be homozygous? Well, let's look at that. Homozygous round, we just did this with R's, so we'll use R's again, with homozygous wrinkled. So when we come in, we're going to fill our Punnett square in. What percentage are going to be homozygous? Well, 0%. Because 100% are heterozygous. So we end up having 100% heterozygous offspring. In pea plants, purple flowers are dominant to white flowers. What parental genotypes would produce offspring that are all heterozygous for that purple trait? So again, capital P, lowercase p, and if we walk our way through here, this is similar to what we did before. That's going to give me my capital. And to get this, I need a lowercase. Again, here, I get this lowercase for there. So I need another capital here. This capital comes there to get that lowercase. So again, I need two capital and two lowercase, which means I need homozygous dominant and homozygous recessive. A white flower plant is crossed with a plant that is heterozygous for the trait. What percent of the offspring will have purple flowers? Well, let's see. I've got a white flowered plant. So that's both lowercase, because white, remember, is recessive. And then it's crossed with a heterozygous purple plant. Because if it's heterozygous, we know that it's going to be purple. So we get the parental genotypes, and we're going to end up with something that looks like this. So this means right here and right here, if we want to know the offspring with purple, that means that 2 of the 4 offspring, or 50%, are going to be purple. The other 50% are going to be white. So if out of 100 offspring, 74 are purple and 26 are white, what are the probable genotypes and phenotypes? So let's think about this for a second. 74 and 26 out of 100, that's pretty darn close to 75 and 25. So again, if I do that, if I have 75%, or 3 out of the 4 that have capital letters, and 25% that have lowercase, then I know this parent has to have a lowercase, that parent has to have a lowercase, but then to get this capital, that dominant, they have to be heterozygous. So we should know by now after doing these that if we have a heterozygous cross with a heterozygous, we're going to end up with a 1-to-1 ratio genotypically and a 3-1 ratio phenotypically, which would be that 74-26. What genotypes would be needed to produce 100% white flowers? Well, let's put our white flowers in here. Again, we're going to use P because that's what we've been using for white and purple. If they're all lowercase, it's recessive. If I want to end up with all recessive for my offspring, then the only thing that we could possibly have is crossing 2 recessive. So to get 100% white flowers, parents need to be lowercase p, lowercase p. In guinea pigs, the allele for short hair is dominant. If all the guinea pigs are born short hair, what's the possible genotypes of the parents? Well, there's 2 possible combinations. One, if all are born short-haired, well, that just means, let's see, let's use S. They all are short-haired. Well, we could have them be 1 capital S here, 1 capital S here. And if we do that, we could cross a homozygous dominant with a heterozygous, which would mean that we would end up with all of them being short-haired. Or what we could do is we could go back and we could change this to homozygous dominant, and it would be capital S, capital S. There's another combination as well, though. If the guinea pigs, if short hair is dominant, if all of them are born short-haired, the genotypes of the parents, we could have a parent that's dominant, homozygous dominant, cross with a recessive parent. Because if we don't know and it doesn't say what the parent was, then they would all be capital S, lowercase s, which again would still show the same genotype. If a second cross is made using these offspring and results are 3/4 and 1/4, what is the exact genotype? So again, what we should see is 3-to-1, and we know when it's 3-to-1 that we're going to need heterozygous. So if we have a heterozygous, then what we end up with is 3 of them being short-haired, and then this 1 here being long-haired. So the parents would be heterozygous. And then the last one, 2 short-haired guinea pigs are mated several times. Out of the 100 offspring, 50 of them have long hair. What's the probable genotypes of the parents? Well, if they're both short-haired, we know that they both have to have that capital, that dominant allele. But they have long-haired offspring, which means there has to be little s's. Now, the only way that we're going to get this, and we'll write it down here, is by having a recessive allele in both. So, though it doesn't necessarily fit perfectly in the Punnett square that we like to see, which is that 3-to-1, anytime that we see the recessive at all, if I'm crossing 2 that have the dominant phenotype, I know that they both, to get a recessive offspring, have to be heterozygous to get to here. All right, if you want to see more, there's one more video coming out. Check the last one out.